ค่ะเชียงใหม่ของเรานะคะพร้อมแล้วนะคะที่จะเริ่มต้นสตาร์ทอัพนะคะอย่างที่บอกไปค่ะนะคะว่าสำหรับนะคะแน่นอนว่ามันจะต้องเริ่มต้นกันก่อนที่ภาคประชาชนนั่นเองค่ะแล้วก็รวมถึงนะคะอย่างที่เมื่อสักครู่นะคะคุณสเวนนะคะได้บอกไปค่ะว่าสำหรับใครที่อยู่ตามชนบทอะไรต่างๆเนี่ยก็ต้องค่ะควรที่จะได้เริ่มต้นนะคะสตาร์ทอัพนั่นเองไม่ว่าจะเป็นทั้งในเรื่องของวัฒนธรรมการศึกษาความเป็นอยู่ต่างๆตรงนี้กันด้วยนะคะดังนั้นค่ะเอาเป็นว่าใครนะคะที่อยากจะลงมือหรือว่าร่วมมือกันตรงนี้นะคะก็ต้องบอกว่าเป็นการสตาร์ทอัพไทยแลนด์เป็นการเริ่มต้นที่ดีเลยค่ะเดี๋ยวหลังจากนี้นะคะเราจะมีคีย์โน้ตนะคะสำหรับสปีดในช่วงต่อไปตรงนี้นะคะที่ต้องบอกว่าสำคัญไม่แพ้กันค่ะซึ่งเราจะมานะคะ Speed Note นะคะตรงนี้กันนะคะ Keynote ใน Smart Elegant นะคะ Culture Case Study High Accurate Centimeter Level นะคะ Utilization Solution Using Quasi-Zenith Satellite System นั่นเองซึ่งตรงนี้นะคะจะได้รับเกียรติค่ะนะคะจากดร. Ryoichiro Yasumitsu นะคะ Director Strategic Innovation Project GNSS Promotion and Utilization Department Speed System Division Mitsubishi Electric Corporation and right now please big clap your hand for Dr. Ryoichiro Yasumitsu ค่ะ
Okay, thank you, Chair, and thank you very much for giving chance to my presentations. Today's workshop is titled Startup Thailand and Digital Island, Digital Thailand. So it is I think it is one of the theme. It's smart city, next generation smart cities. So I would like to introduce the Japanese activities of digital positioning solutions activities. The key of my solutions is using satellite. And my title is High Accurate Centimeter Level Positioning Solutions using QGSS. And my name is Yasumitsu from Mitsubishi Electric's headquarters. And this is the overview of Japanese navigation satellite system QGSS. So I would like to show you the video, the utilization of QGSS.
In fiscal 2018, a 4-satellite configuration for a Quasi-Zenith satellite system using original positioning satellites will be made in Japan. By the end of fiscal 2023, it will become a 7-satellite configuration, with expectations to be used in the Asia-Pacific region in the future. Mitsubishi Electric's 3 core technologies, a Quasi-Zenith satellite system, highly accurate centimeter-level positioning terminal, and a highly accurate 3-dimensional map are contributing to the realization of a safer, more secure, more comfortable society. Positioned almost directly above Japan, the Quasi-Zenith satellite system can deliver positioning signals in most environments, even cities with high-rise buildings or mountainous areas. Furthermore, with services reinforced by centimeter-level positioning provided by the Quasi-Zenith satellite system, the positions of people and vehicles can be identified with high accuracy. The Quasi-Zenith satellite system realizes highly accurate positioning information using positioning signals from the highly accurate centimeter-level positioning terminal. Applying this to various solutions contributes to increasing the service level in each field. For example, by increasing the accuracy of vehicle navigation and enabling the recognition of driving lanes, the system enables applications such as safe driving support and automated driving. Using its innovative technologies, Mitsubishi Electric will develop various types of terminals and expand by offering diverse solutions. In addition to the highly accurate positioning information from the terminal, the highly accurate three-dimensional map provides accurate information for roads, which is essential to safe driving support and automated driving. Mitsubishi Electric's mobile mapping system can create highly accurate three-dimensional map information in real time. Combining the highly accurate three-dimensional map, the Quasi-Zenith satellite system, and the highly accurate centimeter-level positioning terminal enables more accurate positioning information for vehicles and road infrastructure and contributes to automated driving and safe driving support. Moving forward towards the start of services in fiscal 2018, Mitsubishi Electric will continue to create new added value using high-accuracy positioning solutions that incorporate these three core technologies and support various social infrastructure.
Yes, this is a video from QZSS. So I go back to the slide. So as you know, the GPS, that is utilization of car navigations. So Japanese satellite QZSS, it is a kind of navigation satellite, like a GPS. The QZSS is an abbreviation of Quasi-Zenith satellite system, nicknamed Mitsubishi. And in the fiscal year 2018, the Quasi-Zenith satellite system will become a fourth satellite configuration. It's marking a new dawn of a new era, positioning both societies. And the QZS function is increasing coverage and availability more than GPS is only. And it's broadcasting of centimeter level augmented signals. And in the case of GPS signals, it is accuracy level is 10 meters. QZSS and Japanese navigation satellite QZSS is provided centimeter level augmented signals. And this signal services CLAS, centimeter level augmentation services. And this is the service for Asia-Pacific regions. But as for the start of 2018, the certified service area is limited on Japan neighborhood. And this is the orbit configuration of QZSS. And Mitsubishi Electric, that carries out a development in support of the Office of the Cabinet, National Space Policy Cabinet Office. It is government of Japan. The boss is the Prime Minister of Japan. And QZS navigation signal is two kinds of signals. The one is GPS compatible signals. It means L1, L2, L5. And another one is L6 signals. L6 signal is QZS original, Japanese original signals. It is L6 signals. And L6 signal uses, CLAS uses these L6 signals. And as a Japanese navigation satellite needs, the satellite is located on the nearest zenith because Japan has a feature in many urban areas and with high-rise buildings and mountain terrains. But as for one satellite always appear near the zenith like this, about Japan, so it is, we calculate the positioning services. So it is very convenient for the Japan features visibilities. And this slide, this movie is a visibility and they're located in Tokyo. We've taken the fisheye lens. The center point of red point is QZS satellite, like this one. And G is the meaning of GPS. Number is the GPS numbers. GPS is blocked by buildings, signals, but QZS is always appear near zenith. So positioning services is very convenient for QZSS. And QZSS is the final phase is the 7 satellites. So for the 7 satellite configurations, and 3 satellites will be launched on 2017. And now it's on the orbit is 1 satellite, this is the demonstration phase. And operational services will be started in 2018 with 4 satellite configurations, including this one. And QGS Leaf Right configuration will be launched in 2020. And the additional 3 satellites will be launched until 2023. And 7 satellite configuration constellation will be available from 2023. And this is a project plan details. Now is in orbit is only one satellite. This one satellite its purpose is research and development. And the next is the practical phase. And this government authority is first satellite authority is JAXA, Japan Aerospace Exploration Agencies. And from the Block 2 and Block 3, it's a practical phase, and government authority is the Cabinet Office of Japan. And its operation 2018, and satellite mission life is 15 years. And this is, so I talked about this Block 2's as configurations. This Block 2 now going to status, and the Block 2 organization is this one, this slide. This is project functional structure of QGSS, and QGSS project is led by Cabinet Office, this CAO, and under the review of JAXA. And this project is 2 kinds of businesses. The one is the ground segment. It is the PFI business, so special purpose company named QSS. QSS is the Quasi-Zenith Satellite System Services. It's private companies. It is a ground subsegment and operation they carry out. And Mitsubishi Electrics, we are the prime contractor of Quasi-Zenith Satellite Systems. And this ground segment, Mitsubishi Electrics, is CIRAS, Centimeter Augmented Services. QGSS has these 7 services provided, and these 7 services, and this one, it is blue block is the navigation signals. It is compatible with GPS signals. And this orange part is augmented signals. SRAS means the sub-meter level augmented services. And this CIRAS is the centimeter level augmented services Mitsubishi Electric is making. And this PTBS, it is the next generation navigation satellite systems. It is positioning technology validation services. And QGSS is mounted on message services. It is named, one is a DC report. It is satellite report for disaster and crisis management. And using S-band and named QAMP, it is QGSS Safety Confirmation Services. And this is the outline of CIRAS systems. The positioning error is in generally satellite orbit altitude, and satellite clock, and signal biases, ionosphere delay, and tropospheric delay. All of this positioning error calculated by GeoNet. GeoNet is Japan Course Networks. Course is a continuously operating reference stations, and GeoNet, it is 1,300 stations in Japan. So in the CIRAS facility, this GeoNet data analysis, so generating what is the error values. So it is data so generating. So it is compression and via QGS satellite to users. In user, and it is positioning measured with error correction data. So centimeter level augmented services is created. This is the static results of QGS Block 1. It is average in Japan, and horizontal accuracy is about 1 centimeter. And vertical accuracy is about 3 centimeters. Like static means like this field of surveys. And this is a kinematic results, like a car or train, tractors or something. It is the horizontal accuracy is 1.65 centimeters. and vertical accuracy is 1.73 centimeters. It's very good solutions. So I offer the topic, the slightly different point of view on QZSS. For the expanding utilization of positioning services, we think the serious high accurate positioning measure result, it is centimeter level. It is necessary to identify exactly on the map. I mean, serious measured centimeter level with centimeter level map we needed. But how? For generate the high accuracy 3D map, we can use there is a Mitsubishi MMS technology. Mitsubishi MMS is mounted on the car. It consists of optical camera and laser scanners, GNSS receivers. And this is the data of output data of Mitsubishi MMS. This is a 3D point cloud. This is an all-world point, and this is a cloud data and color image data. So, and this from this MMS product for the utilization, the high accurate 3D digital map becomes the basis of the various utilization of positioning services. These high accurate 3D digital maps, so such as personal navigation, disaster management, and automated driving. This is the base of the utilization of the maps. So, such as these personal navigation or something utilization, the small parallelogram is built by an innovative ideas private companies who wants to provide these services. So this small parallelograms area is a business areas. This is infrastructures of Japan. We want to set the future infrastructures. So these high accurate digital maps is building the aims. So we established the companies. The company name is Dynamic Map Planning Company Limited. These characteristics of these companies, the almost Japanese industries is included, and almost map makers of Japan is included. And Mitsubishi Electric takes the initiative in activities to establish the dynamic map planning companies. So I summarize for the utilization of centimeter level accurate centimeter level positioning services, we think the 3 steps is needed. As the first step is created a high accuracy 3D map on the Mitsubishi MMS, like this is Mitsubishi MMS, sorry. This is the Mitsubishi MMS clouded data. All of this point has an accuracy of centimeter level point, altitude and horizontal and height. And from this MMS data, and from this point, this is the first step is auto utilization, and the second step is produced vector data from MMS. I mean, from this MMS data, like this, so this is a pickup for the road informations for the utilization for automated drivings. This from the pickup the MMS data, where is the white line or zebra zone, signals, where is the signals? This is all of the 3D data from the MMS. This is the second steps of utilizations, digital utilizations. And the last step is identify the QZSS, serious high accuracy positioning results on the 3D maps. And I show the results of this point. It is, first, it's, on the snow case, we use unmanned drivings with MMS high correction data and centimeter levels and QZSS serial signals. And another solution is sorry. A solution is this small road automated drivings, like this one. This is the MMS technology and QGS Shiras technologies. And another utilization is robot tractors in smart agricultures. This is because robot tractors, it is this, and next is convoy conformations, is trucks. The distance is this one. This is unmanned drivings, or MMS and QGS signals. So, go back to slides. And this is the expected application field of QGS Shiras. I show that movies. And this is, I summarized the effective application field is one is self-driving support and automated drivings. And the next is effective operation for the railways. And the three is efficient maintenance by precisely monitoring. And the last is advanced unmanned systems automation in various fields. The example is one IT constructions or smart agricultures or drone systems with Shiras receivers. And I show the results of smart agricultures in Japan's test case. This is robot tractors. Frankly speaking, this is 3 years ago test field. This is Hokkaido. It is the north of Japan. And this is the unmanned robot tractors. This test is carried with the University of Hokkaido. With MMS maps and QGS Shiras signals. This is demonstrations. So this is a robot tractors. So they can work on the night. So these robot tractors in the all night test in the using QGS Shiras expectancy field, utilization field, actually. So, I show another results of Shiras example demonstrations. We carried out the many field applications, IT construction, smart agriculture, automated positionings, and railway and mining field. We expected especially automotive utilization and agriculture utilizations. These are examples of demonstrations. It's IT constructions. It is shovel, and it's in the static case, and horizontal error is position accuracy is 0.4 centimeters, and its vertical is about 2 centimeters. It's dynamic, it's a tip of shovel like this one. The accuracy is 1 centimeters and vertical is 2.2 centimeters. And this is the car position results in the mountain area. In the mountain area, hard to look to see in the areas, but ratio of the solution is very good. And this is the trajectory of tsunami buoy moving. This is the first day. This first day is typhoon is coming. But 2 days after typhoon is gone, it's a buoy, tsunami buoy. The moves smoothing. This blue part is first time, the second time, and green is the third time. So tsunami buoy moving this one at a centimeter level. And this is example of cars of demonstrations. And Shira's effectiveness as shown, and this is a highway of Japan's highways. It is good to see the 0.5 under 0.5 centimeters. But here, satellite positioning services is not almighty because, for example, inside of tunnels, over street trees, under street trees, so it needs INS navigation. It is moved adding inertial sensors like this. Without INS, this is only satellite positioning solutions. With INS, and it is recognized in which lane the car is running. And last, I mentioned about the future demonstration in test in Thailand. So its purpose is feasibility study of Shira's in Asia-Pacific region, including Thailand. And as one of the promotion activities like Startup Thailand or Digital Thailand. And this, we want to go and carry out a step-by-step approach concept. As a first step, static test, for example, post-processing analysis near Chiang Mai. And next step is static test, but real-time test. And the last step is a kinematic real-time test for specific application. Examples, automobiles, agriculture, mining, etc. And its demonstration test candidate date is after next years, because the QGIS satellite starts at 2018, so QGIS satellite is the final phase of making the industries. So after next year, we want to then these demonstrations in Thailand. This is the test configurations of in Thailand case. If this Shira's needs the course networks, so in Thailand test in Shira's, we need the Thailand course networks, like Royal Thai Survey Department or something, course networks. So it is the sent to the by internet and Shira's facilities Japan, and case one by satellite links. So case two is the ground systems, such as internet or something. And case three is post-processing in Japan, and by satellite ground systems, so Thailand receivers, setting in Thailand in these receivers. So this is demonstration test in Thailand systems. So this is the conclusions. And in fiscal year 2018, the Quasi-Zenith satellite system will become 4 satellite configurations. It is marking the dawn of a new era of positioning-based societies. Mitsubishi Electric carries out QGIS development in support of the Office of National Space Policies, Cabinet Office, Government of Japan. And we are working to realize highly accurate positioning solutions by broadcasting centimeter-level enhanced positioning data from QGSS and its data matching it with highly accurate 3D-dimensional mapping created by Mitsubishi Mobile Mapping Systems. And in addition to, we are contributing to the innovation of various social scenes in areas such as safety driving supports and automated driving, as well as like railways, smart agriculture, and IT construction. In near future, QGIS Shira's demonstration test in Chiang Mai is mentioned. So I have enclosed introducing about high accurate centimeter level positioning services. So I look forward to the opportunity of doing work with you. Thank you.
Thank Dr. Ryoichiro Yasumitsu, Director, Strategy Innovation Project GNSS Promotion and Utilization.